Hello everyone, welcome to the lecture series of pattern classification. I am Kundan Kumar, and if you would like to have these lecture slides, you may refer to my GitHub page at this given link. In this lecture, I will introduce you the pattern classification and its application in broader sense. Currently, artificial intelligence and machine learning is the best tool to deal with many real-time applications where an accurate decision is very much required without any human intervention. Basically, the term artificial intelligence was first coined by John McCarthy in 1956 during an academic conference. However, Arthur Samuel coined the term machine learning in 1959 at IBM. Similarly, the different terms like soft computing, data mining, neurocomputing were coined by different domain experts, but these domains are overlapped to each other as shown in this diagram, or you can call it as the Venn diagram. Okay, so if you look at the pattern classification, so this green circle shows the pattern classification. It overlaps with statistics, machine learning, artificial intelligence, and many other domains. So in my opinion, there is no clear demarcation among these domains. So let us look at the definition of artificial intelligence and machine learning, and we'll try to relate the pattern classification with these two domains. The term artificial intelligence comprises of the two words, okay, the artificial and intelligence. Artificial refers to something that is made by human intelligence, mean ability to understand or think. By definition, artificial intelligence is the theory or development of computer systems able to perform tasks normally requiring human intelligence, such as recognizing faces, speeches, decision making, or translating from one language to other. So here, to give the intelligence to the machine is to be trained and can learn by its own from the given data without being explicitly programmed. So here it is very important to notice that the machine can learn by its own from the given data without being explicitly programmed. That means it should not be programmed. Okay, automatically it should learn from the data, and so called machine learning. So this is the field of computer science that uses statistics techniques to give computer system the ability to learn without being explicitly programmed, and the most important part is that it should progressively improve performance on a specific task. Okay, and when we look at the pattern classification, the pattern classification comprises of two words, pattern and classification. Means pattern classification deals with the classification of patterns or finding regularities, or we can extract the regularities from the data based on some prior knowledge or some statistical information. Vaguely, we can say that the pattern classification is a subset of machine learning. Okay, because machine learning also does the same kind of thing as the pattern classification does. So here we deal with some feature extraction as well. That means we can say that the pattern classification is a subset of machine learning, but the machine learning does not deal with feature engineering wherever the pattern classification does. It deals with the features. Also, the pattern discovers the regularities in the data through the use of learning algorithms. Pattern recognition and pattern classification are very similar words, okay, but there are a very small difference that in pattern recognition we recognize a pattern, and in pattern classification we classify the patterns. Okay, so it's simple to understand that the pattern recognition and pattern classification are very similar words. The only difference is that to recognize any pattern, first it should be classified. Okay. So already we know that we human being have 5 sensory organs like eye, ears, nose, skin, and tongue. I'm not talking about the sixth sense. Okay. So these sensory organs give us the capability to visualize, to hear, to sense the smell, to sense the surrounding. Okay, by the surrounding we can sense using all these sensory organs, and also we can taste using our tongue. So we have these sensory organs to understand or to sense our environment, to sense our surroundings. Okay, so these are the sophisticated skill for sensing the environment and taking action what we perceive. For example, recognizing faces, written digits. Okay, so there are many actions, okay, that we do. Many of you are able to recognize few faces shown here. That means you are able to learn from the environment what you perceived. That means in future might be you have seen these faces and you are able to recognize now. Also, human can understand the spoken words that we speak and able to read very complex handwritten texts. Human can also distinguish the aroma of rose from the aroma of an onion. Okay, because their smell are totally different, and our sensory organ it distinguishes between these aromas. So we human do these tasks without any difficulty and do in fraction of seconds. We would like to give that skill to the machine. So that is our objective. Okay. However, it is very difficult for a programmable computer to solve these kind of perceptual problems. These problems are difficult because each pattern usually contains a large number of information, and the recognition problem typically not clearly visible structure in high dimensional space. So we have to develop our system or pattern recognition system in such a way that it should able to perform these tasks without any human interventions. But we should understand that without any human interventions, is it possible to complete all those tasks? I don't think so. Some human interventions will be required, because if you talk about the artificial intelligence, if a robot is there, it performs the task by their own. But who designed that robot? Who have written the thousands of lines of code to perform a task? We human beings have done those things. Okay? So, but I mean to say that human intervention should be minimized. Okay? So, let us talk about what is pattern. If you will perceive from the surrounding, then you will observe that every human being have the different fingerprints. Someone gives their fingerprint in the offices for their attendance. So why they use their fingerprints for their attendance? Because the individual persons having their fingerprints unique. Okay, so it is kind of pattern for that person that is unique, that uniquely define that person. Okay, maybe the pattern is the handwritten word. That means the someone doing their signature are different. So some other patterns like human faces are also very different to each other, like speech signals. So these are the basically the patterns that we can perceive from the environment, and we can make our decision based on these patterns. If we will perceive these patterns, then we can make our decision based on this. Also, the pattern is not only the objects. These are objects. Okay. So pattern is not only the object. It could be object or event as well. Okay. So it can be biometric, face, palm, signature, speech. But if you talk about the event, then you can talk about the how the person move, how the person talk, how they walk. So that is the basically event. That means a marriage ceremony is totally different from a birthday celebration. So you can think of that these two are different events. Their characteristics are different. So we have to perceive, we have to extract the patterns from the data, from the surrounding. Okay. So these are the different types of patterns. So patterns, we can have lots of patterns that we need to find. So we humans are very sophisticated to extract the different types of patterns. So as I told you that we are trying to give this kind of skill to the machine, that whether machines are able to distinguish these type of patterns or not, whether machine can extract these type of patterns or not, whether machine understand these type of patterns or not. Okay, so once the patterns will be extracted, okay, it should be classified. That the machine should tell that what is the action is going on. That means some decision should be taken care. So a pattern classification system, basically it observes the environment first and then learn to distinguish patterns of interest that just I have shown you, that was just the few examples, and then need to make a very reasonable and sound decision about the categories of the patterns. Like, suppose we have to classify apples and oranges. So what kind of the features that we should consider? Is the color is sufficient to distinguish the apples and oranges? Might be the color is not sufficient information. We should consider the shape of the apple and oranges as well. So if we consider the patterns which will distinguish these type of objects, then our the decision making system will be able to categorize the patterns. Okay, but the question is that how we can model such kind of pattern classifier, how we can model the pattern classes, like the apple was there or orange was there. So if we pick up any random fruit, that means, and I will ask to the machine that this is which fruit, so how the machine will make the decision? So definitely machine has to make some model for that, and the model should be for a complete task. For individual task we should have one model, or we can have a generalized model as well. That is the goal of the pattern classification. So usually we model our pattern classification problem using the statistical techniques. We use the statistical features. We study the features in the statistical environment to extract the or to study the distribution of the feature vectors, and that distribution gives us the model of the pattern class. For example, suppose we are dealing with the gender classification problem. Okay, so we are dealing with the gender classification problem, and here we have to classify male and female. So we can extract some kind of features, okay, from the male images as well as from the female images. And from the female images, we will construct some kind of distribution, okay, using the statistical model. And that distribution, maybe it is Gaussian as shown here. Similarly, we can have the probability density function or the statistical model for the only male persons. Maybe this is the kind of distribution for male. So this model can be used to perform the gender classification problem. Somewhere we can put the threshold value, and we can say that if some feature is less than this threshold, then we can say that it is male, or if it is greater than threshold, then we can say that the person is female. So we have to model it, okay, and statistical model is well adapted approaches. So here lots of application of the pattern classification in computer vision for different types of applications, different types of tasks to perform in the computer vision. We have to use the pattern classification. It observes the environment, it extracts the features, and then it make the decision based on the information it gathered from the environment. So let us see some applications where we can use the pattern classification systems. So these are the just few applications where we can use the pattern classification system, like speech recognition. Suppose we want to convert from speech to text, then speech recognition system, it will work. It records the voice and it converts the utterances into the text, so that the complete voice will be converted to complete text. So this is the speech recognition that we can perform. We can perform the biometric recognition, biometric identification, as I have given to the example of the biometric attendance system in the offices. Fingerprint identification. This is the implementation of the biometric attendance system. We can have the face recognition system. At the airport, for security purpose, the face recognition system can be used. The security system will detect the suspect based on the gesture or based on the face information. It will recognize the face. If some suspects will be there, it will recognize that face and it will give the alarm to the security. It can be used for optical character recognition. That means it will convert handwritten text to the computer text. Optical character recognition. You might be heard about the MNIST dataset, which is very famous dataset that is used to train a model which convert from handwritten text to the computer text. We have the other application like DNA sequencing. It defines the DNA. It extracts the DNA sequence from the different types of animals. It can detect the human race. The lots of application it has. It has also application like the autonomous navigation. You might be you have heard about the car, autonomous car. You might be heard about the Google car. You might be heard about the Tesla car, which runs without the driver. It is totally autonomous. How it works? It observes the environment. It extracts the environment features, and then it makes the decision that where we should go. Okay. So here, as I've told you that for the speech recognition, it captures the voice and it extracts the features, and the extracted features, it captures the utterances with respect to different words, and it stores in the training data set, and it creates a model. And then when the unknown speech comes, then it uses this model to convert the collected speech signal to the text. It performs the pattern matching from the trained model. That means it converts from the speech voice to text. Let us consider the other applications in the biometric recognition. So there are many biometric systems like fingerprint. Every person having the different fingerprint. Iris. In our retina, we have iris. Sorry, retina is the back portion. Iris we have in just on the front position of the eye. So iris having a very different characteristic for every person. Face, every person having a different face. Speech, the voice, the person can be distinguished by voice. So these are basically the different types of biometrics. So the people use the pattern recognition system in the biometric recognition system. for different type of applications. We can use the OCR characteristics, that means OCR character recognition system. So first it captures the images and then it convert to the boxes, and then each character is recognized by OCR model that which computer alphabets are there, and then it combines to a single computer word. So how this optical character recognition system works? It is used in the cancer detection problem, like the benign and malignant cells. So doctor will see that this skin samples, and doctor will see in the microscopic. So this is the basically microscopic tissue, and doctor will see in the microscope, and then he or she can tell that the cells are malignant or benign. If it is benign, then it is non-cancerous. If it is malignant, then it is cancerous. So lots of application. This application is in biomedical engineering. It boosts the health sector. You can see the other application like in the land cover detection, or in case of vegetation. You can consider the example of the Amazon forest, where the fire catch the Amazon forest. So how the people will find that how much the damage have occurred due to the fire? It is from the satellite image. The satellite image will capture the Amazon forest, and maybe it will have, that means some prior images, and it will compare those two images, and based on that it can tell that whether, that means how much damage have occurred because of fire. In this image you can observe that there are different like grass, crop, ground, buildings. So these type of areas can be classified. It can be distinguished in the images from the satellite images. That means in the satellite images, and these images are captured from the satellite. And now these days we have a very good satellite images, very high resolution images. Now let us see a classic example to understand the pattern classification. Now let us see a classic example to understand the pattern classification problem. Okay, and we will use this problem to discuss the other model. Okay, so suppose we have an application of sorting incoming fish on conveyor belt. Okay, so suppose somewhere the fishing area, okay, and there our objective is to categorize the two type of fish, and that fish will come on the conveyor belt where the camera is to be mounted. Okay, so here suppose we have the two fish, sea bass and salmon, and it is coming on the conveyor belt where the camera is placed over there. So it will extract the different types of features from the images captured by the camera, and that features may be the length, lightness, width, number, shape of fins. So because these two fish having the different characteristics, and these characteristics need to be considered, because the lightness of these two fish is a very distinguishable feature. That means if we consider the lightness amount, then it will categorize the fish. Okay, so there are other features as well, like length, width. Even you can notice the fin position. If certain algorithm we can apply that will detect the fin position, then we can extract some numerical value from that, and that will act as a feature. So we can have the different types of features. So suppose the length, lightness, width, number of fins, and the position of mouth as well. These are the features in this problem. Okay. So first we need to perform the pre-processing. Okay. So in the pre-processing, basically we check the lightning condition of the conveyor belt. Okay. That means the lightning condition under which this model will be developed. So suppose we have mounted our camera somewhere and that area will be dark, then it is pointless to consider the lightness feature. So we have to consider the lighting condition, because it will capture the image. Image is always corrupted by the amount of light. If the amount of light will be less, then image will be noisy. And also we should take care of the position of fish on the conveyor belt. So from this example, I want to convey that what are the things we should consider when we perform any pattern classification problem. We have to think about that what are the problems may occur, what are the external factor will affect our pattern recognition system. See, the camera noise itself can affect our performance of the pattern classification system. So these things comes under the pre-processing. To make this problem to be simple, we can do one more thing, that we can isolate the feces, because when we will have the multiple feces and overlap, then it will be difficult to extract the features. So for this problem, we can put the face on the conveyor belt and those feces will be isolated, so that it will be easier to distinguish the face. It will be easier to extract those features. And once the features will be extracted, and then our classifier will make the decision that whether it is salmon or sea bass. Okay. So for the extracted features, we need to create our model. As I told you that we can create our model using the statistical model. Whatever the features we have extracted, and we perform the statistical techniques on those features to obtain our pattern class, the model for the pattern class. So suppose we have two class here, salmon and sea bass, because we have the two fish. So it is a two class problem. And if we are considering the length feature, then we can estimate the distribution of these two class. So here histogram is shown as the estimation of the distribution of these fishes, these two different classes samples, and we will create this distribution using the length feature. So only one feature we are constructing here. So here we have two different class and two different distribution. So if we put threshold somewhere, suppose here if we are putting some threshold, then we can say that the left side, that means suppose L star is the threshold, then the value of length less than L star will count the fish as salmon. Otherwise it will tell us that the fish is sea bass. But you can observe here, using this distribution, you can find that some sea bass are on the side of salmon. So these shaded areas are nothing but the erroneous result. That means we are encountering this much error if we put this threshold to make the decision. So this error is only for the sea bass. We may have the other error as well, because the some portion of salmon fish is on the side of sea bass, like this one. So this is the error. So the total error will be the shaded area that I am shading here. So just observe that how much area I have shaded. So this much error we have to encounter if we put the threshold something like this on the length feature. That means a single feature is not sufficient to make an accurate decision. So what we can do? Definitely we can add more number of features so that the error can be reduced. So let us consider the another feature, that is lightness. This is also only one feature, but this feature is better than the length. So lightness is better feature because it's simple to say that it has the less error, less number of sea bass which is classified to salmon, and less number of salmon which is misclassified to sea bass. So lightness is better feature compared to the length. So these two features are individual features and their performance is different. But what if we combine these two features? Can we combine it? Whether it will improve the performance or not. So we can combine the two features so that it will improve the accuracy of the classification. So in that case, we have to make the feature vector. That means not only one feature. If we consider more than one feature, then it will make a feature vector. So suppose we have considered the two features, that is lightness and width, then we can make a feature vector x, which is written as upright x. So please note down here that in this complete course we will use the upright x for a vector and the small letter for scalar. Okay, so here x is a column vector because here we have used the transpose. So now when we are making the feature space using these two features, then might be the decision boundary will be something like this. Classify all the samples. So it will be very complex. Then we have to generalize our model so that we will get something like this. That means it should work on the test data samples. Okay. So here these dots are basically, it represent a fish having the lightness value and the width value. So the two-dimensional feature vector, it is a point in two-dimensional feature space. Okay. So we might add other features that are not correlated with the ones we already have. So in that case, we have to take the precaution, and it should be taken not to be reduced performance by adding such noisy features. So we have to be careful that what kind of feature we are adding. If it will introduce noise, then we have to be careful about that. It will give the worst performance when we classify our data samples, when we will classify our feature vectors. So one thing can be keep in mind that whatever the classifier we are using, just you think that classifier is very good, but if your feature is not good, then the classifier will not do anything. It is not possible for the classifier to classify the feature vectors if the feature vectors are noisy. The classifier will fail there. Okay, so in that case, we have to avoid the unreliable features, and we have to be very careful to avoid the correlation, that means correlated features. That means we have to avoid the features which are highly correlated with the existing features. Because if we will have more number of features, then maybe the computational cost will increase. When we will deal with the high dimensional feature space, then computational cost will be very high. Then sometimes we reduce the dimensionality of the feature vector just to reduce the computational cost, so that our model can perform efficiently in the specified time limit. And also we have to be very careful about the measurement noise, because in which environment we are collecting the data. So if we collect the voice signal from the very noisy environment, maybe on the traffic, then it will be very difficult to convert that speech to text. That the model will be very complex. Okay. Is there some curse of working in high dimensions? Because when we go higher to higher dimensions, the computational burden will come, and might be the accuracy will not be the accuracy will not achieve how much we want. So that means if we keep adding the dimensionality, it will improve the accuracy. Is it necessary that every time it will happen? So we have to be careful. So there is the curse of dimensionality that we will study in the dimensionality reduction chapter. So here you can see that I think this part is already I have discussed, that if we can have the complex the decision boundary, so it will increase the complexity of our algorithm. So if some unknown samples are coming here, then whether it will go to class Salmon or CBAS. So by the simple distribution, it seems that it should be in Salmon, but according to this boundary, it is going in CBAS, because this boundary is basically the very complex boundary. This is not generalized, because this is working good on the training data set, but this is not working good on the test data set, because this boundary, it learns. That means it is not learning at all. It is basically memorizing these data points. So this model, it is memorizing the feature vectors. That is why this a very complex boundary we are getting. So our model should be very generalized, something like this, like just I've shown you here, so that if boundary will be something like this, then this sample will be classified to Salmon, and that should be, because this is unseen data sample, unseen feature vector. Our objective is to classify the unseen feature vectors, unseen fishes, unseen fish, whether it is Salmon or CBAS. So how we can manage the trade-off between the complexity of decision rule and their performance to unknown samples? So that is basically the issue of generalization. So our satisfaction is premature because the central aim of designing a classifier is to correctly classify the novel inputs. We have to focus on the novel inputs, not on the training feature vector. So this is the basically the issue of generalization. So we have to generalize our model in this way, not the complex data, so that it is not learning the feature vector, it is memorizing the feature vector. That is called the overfitting. It will come in the future lectures. So something like this. Okay, so this much for this lecture. uh, in the next lecture we will discuss this pattern recognition system and design cycle. I hope I'm clear to you. If you have any doubt, you can ask in the comment section. Thank you.